Hi everyone, today we're going to be talking about solving and graphing linear inequalities. So first we're going to learn about inequalities. Inequalities is basically when you're saying that one quantity is either less than, greater than, less than or equal to, or greater than or equal to another quantity. So here I've broken down all the symbols for you. So on our first symbol over here, so this is the first one, we have less than, and this is the symbol for less than. So basically, we're going to put like a number and it's less than this. So we know 8 comes before 9, and 8 is obviously less than 9. So let's do 8, and let's use our symbol less than 9. Get it? Okay, so our next symbol is going to be greater than. So greater than is basically like the opposite. So it opens to the right, like it closes to the right. So I'm going to teach you a trick on how to identify, but first let's do an example. So we know 10 is greater than 9, obviously. So we'll do 10 and our greater than symbol and 9. So as you can see, we have our greater than symbol showing that 10 is greater than 9. Now, how I like to think about this is if the crocodile mouth is open, facing a number, that means that's the greater number. So let's take the numbers of 1010 and let's take the number 1011. Let's draw our greater than symbol or less than symbol. In this case, since 1010 is less than 1011, we're going to do this. And it's the opposite. Okay, we're going to do this. And as you can see on the right, we have the crocodile mouth is kind of open. It's opening to the wide, to the greater number. And then as you can see, the tip of it is at the smaller number. And that's how I like to think of it, because these are interchangeable. You could also write this as 1011 is greater than 1010. But it doesn't really change because we just switched it around and our crocodile mouth is still facing, it's like still open towards the greater number. That's just one way how I like to think about it, and it makes it a bit easier. Okay, so now we're going to do our next inequality. So it's less than or equal to. What this basically means is that one number is either that number or less than it. So it's shown by this. It's basically just the less than symbol with a line underneath, like kind of like an equal sign, but just one line. And this is our third type. So what we're going to want to do now is take an example. So let's do, normally you only get these symbols in like equations and stuff, or inequality equations, but in this case, it's not like that. So let's just do 9 is less than or equal to 9. Now I know that does not make much sense because we normally do this with variables, but I'm trying to show you that 9 is either equal to 9 or less than 9. So as you can see, 9 is equal to 9. This inequality will also hold true if you put an 8 here, because even though 8 is not equal to 9, it's still less than 9. So that's what it means by less than or equal to. Normally they do this with variables, so we put a variable over here like x. That means any number can be substituted for x if it's less than or equal to 9. So that means x can be like, it can be 9, it can be 8, it can be 7, 6, 5, so forth. Okay? So that's kind of how that works. And our last one is the same thing, but for greater than. So it's greater than or equal to. As you can see, our symbol is the greater than sign with a line underneath, and it can be greater than or equal to. I'm going to show you with a variable this time because using numbers just doesn't make much sense. So let's do y is greater than or equal to 4. That means y can be anything from 4 and beyond. So 4, 5, 6, it can be anything, an infinite number of numbers. So it's basically equal to shows you that it can be that quantity, so it can be 4, but it can also be anything greater than 4, and you can basically substitute anything. So let's go into solving linear inequalities and graphing them. Okay, so this is our next first example. We have 2x plus 7 is less than or equal to 9. So first thing you're going to want to make note of is note that the quantity on the left, so 2x plus 7, is less than or equal to 9. So whatever number you substitute for x, it has to make sure this entire thing, so 2x plus 7, so multiplying x by 2 and then adding 7 to it, the whole contraption it needs to be less than or equal to 9. Now, you don't need to randomly on the spot think of numbers. You can actually just solve this like a basic linear equation. So let's solve this. First, to solve a linear equation, if you have no clue what I'm talking about, I suggest you check out some of my past videos on solving linear equations. But first thing you're going to want to do is isolate the variable x. So to do that, we're going to get rid of this term. So we're going to get rid of the 7. To get rid of 7, you subtract 7 from both sides. Whatever you do to the left, you have to do to the right, so don't forget to do that. And you'll get 2x is less than or equal to 2. Again, if you're really confused, please check out my previous videos, but just for a short explanation, 9 minus 7 is equal to 2, and 7 minus 7 is 0, so you just don't include it. We're basically just getting rid of that second term on the left-hand side, and we're basically step-by-step bringing the x to it by itself. Okay. So x is less than or equal to 2. Okay, so now we're going to want to get rid of this 2 over here that's right next to the x. Since it's being multiplied to the x, you can just divide 2 on both sides and still get it. So let's do 2x divided by 2 and then divided by 2 on the right hand side as well. What would we get? X is less than or equal to 1 because 2 and 2 cancel, giving x, and 2 and 2 cancel, giving 1. So our finalized, since the x is by itself and there's no other number next to it or on another term, x is less than or equal to 1. That's your final inequality. Now, sometimes you'll be asked to graph these on a simple number line. So a simple number line is basically just what you've seen in school. It's a number line with numbers. So I'm going to put 1, 2, 3, 4, and 0, -1, and -2. So that's just a basic number line, and sometimes they'll tell you to graph your inequality on a number line. It's not hard. First thing you're going to want to do is put a circle above the number. So here we have the number 1 in our inequality, so we're going to put a circle above that, just a little circle. And next what we're going to want to do is draw a line corresponding to what the values of x can be. In this case, the values of x can be less than or equal to 1. So you're going to go to the left because anything to the left of 1 is less than 1 on a number line, right? If you do this by mistake, that means you're showing that x can be greater than 1, which is not what we want. The third step, which honestly you should do in the first step, but you should take note of whether your equation says less than or equal to or greater than or equal to. So if it says greater than or just greater than or equal to. So there's a difference between graphing this and this on the equation. When you're graphing this on the number line, you just used a plain circle, but if you're graphing this, you need to shade in that circle. So in this case, since it is less than or equal to 1, we're going to shade in this circle. Sometimes you can do this on the spot when you're drawing your circle, but I just wanted to make it clear. So we have our shaded circle here, and basically all that shows is that x is it can be 1 or anything less than 1. If this was just going to be like, let's say, a plain circle, that means it's not 1. It's anything less than 1, but it's not equal to exactly 1. So in this case, it is equal to 1. So we shade in the circle and we draw the number line to the left. So your final inequality would be x is less than or equal to 1, and this would be your number line. Let's do another example. Okay, so this is our next example. We have -5x minus 5 is greater than or equal to -25. Now, as I said before, don't let the negative signs confuse you. We're just going to do the same thing. So we're going to want to make the x isolated. In this case, we have a -5 right next to it, so we're going to get rid of that by adding 5 on both sides. If you add 5 on both sides, you'll get -5x is greater than or equal to -20. Again, I just did -25 plus 5 and -5 plus 5. So now we have -5x is greater than or equal to -20. Now what you're going to want to do is get rid of the -5. You're going to want to make it a positive x. To do that, you would just divide both sides by -5, right? So that way your -5's cancel and you get an x on this side, and here your negatives cancel and you get 20 divided by 5 is just 4. Now there's one very important thing that you should take note of. When you have a negative next to your x that you're removing, so in this case we are removing it because we're dividing it by -5, your sign flips. Nothing happens to the less than or to the equal to, but it flips, so like it becomes this. So instead of being greater than or equal to, it now becomes less than or equal to. And as you can see, now we have x is less than or equal to 4. Just to show you that example one more time, we're going to do -3x is less than or equal to 9. And it doesn't work when you're doing just positive 3x is less than or equal to -9. It only works when when the negative sign is with your x. Now in this case, it's not with our x, it's with the -9. So in this case, we would not flip around the symbol over here in the middle. But in this case, in the bottom over here, we have -3x. So we're going to divide both sides by -3, and we're going to get x is greater than or equal to -3. So make sure that's a mistake that everyone makes, but if you understand it, you won't make it again. So let's draw this on a number line. Again, just a basic number line. Let's put 4. I normally only put 2 numbers above and below. And that's normally enough, but if you have to do an entire number line, it's no different. I just did this for compactness, I guess. And let's draw it. So we have less than or equal to, as I said before, you're going to draw a circle above your number and we're going to shade it in because it's a less than or equal to. And then we're going to have our x is less than 4, so we're going to draw the line to the left. So it can be anything from 4 and below. So let's do another example. Okay, so this is our next example. We have a negative 2x over 3 is less than 9. So let's do this step by step. As you can see, we only have one term, 2x over 3, well, negative 2x over 3, and one term on the right, so it's 9. Now, as I said before, we want to get the x isolated. The first thing we're going to want to do is remove the denominator. To remove the denominator, if you have 1 over 3, if you multiply by 3, it gets 1. So we're going to multiply both sides by 3. So 3 on the right, on the left, and 3 on the right. 3 and 3 will cancel, giving you negative 2x less than 27. And then now comes our next step. Now, as you can see, we have negative 2 attached to the x. So if we divide by negative 2, as in our previous example, we would get, we would remove the negative and we would remove the 2. Now, this is the most important part. You know that this will come down to x and this will come down to negative 27 over 2. Now, that's a given. But we need to switch the sign of our less than. Our less than will now become greater than. So this is our final inequality. I'll write it again over here. X is greater than negative 27 over 2. Why? Because if you're removing a negative from the x, so from the left-hand side or wherever the x is, you're going to want to flip the sign. Okay, so we have negative 27 over 2. First thing I'm going to do for simplicity's sake is change this negative 27 over 2 to negative 13.5. So our final inequality will be x is greater than negative 13.5. So negative 13.5. And then we have a number line down here at the bottom. Let's do negative 13.5, negative 13, and negative 14. And then let's do our number line. So first we see that x is greater than. Now on a negative realm, greater than is always to the right. So since it's not greater than or equal to, we just put a basic circle and draw a line to the right. And that's it.